Imagine looking up at a familiar street corner. You see the traffic light, that silent guardian of the intersection. It cycles through its commands: red for stop, green for go, yellow for caution. For over a century, this simple trio of colors has governed the chaotic dance of vehicles, a language understood by drivers everywhere. But what if a new color joined this trio? What if a fourth light appeared, one that doesn't speak to you, but to the car itself? This is not a scene from a distant science fiction future. It is a concept emerging from the minds of engineers and city planners today. The white traffic light is a proposed addition to our urban landscape, a beacon designed specifically for a new kind of driver, the autonomous vehicle. This new light represents a profound shift in how we think about traffic. It is a signal of cooperation, a symbol of a future where human drivers and intelligent machines share the road. The white light is not meant to replace the system we know so well. Instead, it will augment it, adding a new layer of information to the symphony of the streets. It is an evolutionary step, much like the first traffic signals were an evolution from a police officer directing traffic with hand signals. We are on the cusp of teaching our cities a new language, one of computation and connectivity, all in the service of a smarter, more efficient world. The introduction of this simple white light is a quiet revolution hiding in plain sight. The idea might seem strange at first. We are so accustomed to the red, yellow, green pattern that adding another color feels almost unnatural. But consider the universe. It is filled with signals we cannot see, from radio waves to infrared light. We build instruments to detect these signals and learn more about the cosmos. In the same way, the white light is a tool. It is an instrument that allows our traffic infrastructure to communicate directly with the growing fleet of autonomous vehicles. It's a way of letting the machines take the lead when they are ready, guiding the flow of traffic with a precision that human senses alone could never achieve. This is the dawn of a new kind of urban intelligence. So, as we stand on the precipice of this change, let us explore this fascinating concept. Let us journey into the heart of the intersection of the future. We will look at how this white light will work in harmony with the colors we already know. We will uncover the hidden technology that allows cars and traffic lights to speak to one another. We will explore the cosmic scale benefits this could have on our daily lives, from saving time to saving lives. The story of the white traffic light is not just about a new piece of technology. It is about the next chapter in the human story of movement, community, and our unending quest to build a better world. The traffic light system we use today is a beautiful, simple piece of logic. Red means stop, green means go, yellow warns that the signal is about to change. These rules are universal, allowing millions of people who have never met to coordinate their movements safely. The white light does not seek to disrupt this elegant system. Instead, it adds a new verse to the song of the intersection. When the white light is on, it is a message to human drivers. It says, follow the car in front of you. It's that simple. You don't need to interpret the red or green lights anymore. Just maintain a safe distance and do what the vehicle ahead of you does. So, when does this white light activate? It turns on only when a sufficient number of autonomous vehicles are present at the intersection. Imagine a critical mass of these smart cars approaching the corner. They begin communicating with the traffic light and with each other. They collectively determine the most efficient way to cross the intersection. At this moment, the traditional red and green lights for that direction might turn off, and the white light would illuminate. For the human drivers mixed in this group, the instruction is clear and intuitive. You are now part of a coordinated platoon. The autonomous vehicles are leading the way, and your job is simply to follow along with the flow. What happens if you are a human driver and you are the first car at the light? Or what if there are not enough autonomous vehicles to take control? In that case, the system reverts to what we know. The white light remains off, and the familiar cycle of red, yellow, and green takes over. You will stop on red and go on green, just as you always have. This is the genius of the design. It is a transitional system, built for a world where humans and robots must coexist on the roads. It doesn't require every car to be autonomous overnight. It allows for a gradual integration, adapting to the number of smart cars on the road at any given moment. This dual system ensures that no one is left behind. It respects the decades of driving experience held by humans while simultaneously unlocking the potential of machine intelligence. The white light acts as a switch, toggling between two modes of operation. One mode is the classic human-centric system we have relied on for a century. The other is a new machine-led system that prioritizes hyper-efficiency. The light itself is the messenger, telling human drivers which system is currently active. It's a simple visual cue for a very complex and powerful computational process happening behind the scenes, a beautiful fusion of old and new. The magic behind the white light isn't in the bulb itself, but in the invisible conversation happening all around it. This is made possible by a technology known as vehicle-to-everything, or V2X communication. Think of it as a wireless language that allows cars, traffic lights, and even pedestrians' smartphones to talk to each other in real time. It's a constant stream of data, a digital chatter that paints a complete picture of the traffic environment. An autonomous vehicle using V2X doesn't just see the car in front of it. It knows that car's speed, its intended direction, and whether it's braking, all before its brake lights even turn on. It's like giving the car superpowers of perception. When a group of autonomous vehicles approaches a V2X-enabled intersection, they don't just wait for a signal, they announce their presence. Each car sends a message to the traffic light's central computer, saying, "I am here, I am traveling at this speed, and I want to go straight." The traffic light controller, which is now a powerful computing hub, gathers these requests from all directions. It's like a cosmic switchboard operator, listening to dozens of conversations at once. It processes this information instantly, understanding the exact position and intention of every connected vehicle within its range. This is a level of awareness far beyond what any single human driver could ever hope to possess. This digital dialogue is the key that unlocks the white light phase. The intersection's computer analyzes the data from all the approaching autonomous vehicles. It runs complex algorithms to calculate the most efficient and safest way for all of them to pass through. It might decide to let a group of cars from one direction proceed together, or it might create a perfectly timed sequence for cars from multiple directions to weave through without ever needing to stop. This calculation is what traffic engineers dream of, a perfect, optimized flow. Once this optimal plan is decided, the computer sends a command back to the traffic light to activate the white light. Simultaneously, the central computer sends instructions back to the autonomous vehicles themselves. It tells them, "You are cleared to proceed at this precise speed, or you will be part of the second group to cross." The cars receive these commands and execute them with machine-like precision. They accelerate, decelerate, and move in perfect harmony, like a flock of birds or a school of fish. It is this unseen high-speed conversation between the cars and the intersection that creates the seamless, efficient dance of traffic. The white light is simply the visible sign to us humans that this intricate, beautiful, and invisible process is underway. Let us dive deeper into what happens during this white light phase. When the central computer at the intersection determines that enough autonomous vehicles are present, it initiates a new mode of operation. It effectively hands over control of the intersection to a distributed computing network formed by the vehicles themselves. The traffic light is no longer the commander, it becomes a coordinator. The autonomous vehicles, communicating with each other at lightning speed, negotiate the crossing amongst themselves. They become a single intelligent entity, a temporary superorganism with the sole purpose of moving through the intersection as efficiently as possible. This process is governed by sophisticated optimization algorithms. These are mathematical recipes that solve a very complex puzzle: how to get the maximum number of vehicles through a shared space in the minimum amount of time without any of them colliding. The algorithm considers variables we can't even process, like the acceleration capabilities of each car, the exact distance between them down to the centimeter, and the flow of traffic blocks away. It can then choreograph a ballet of vehicles, timing their movements with millisecond precision. A group might pass through, followed immediately by another group from across street, weaving together in a pattern that would look terrifying and impossible to a human driver. For the human drivers who find themselves in this mix, the experience is designed to be simple and stress-free. The white light activates, and the instruction is to follow the vehicle ahead. If the car in front of you is an autonomous vehicle, it will move according to the grand plan calculated by the algorithm. It might slow down slightly, then speed up, all as part of the coordinated flow. Your task is simply to mimic its behavior. You become a passive participant in this highly efficient dance. You are letting the machines handle the complex thinking, freeing you up to simply drive. This reduces the mental load and anxiety often associated with busy intersections. This phase continues as long as the density of autonomous vehicles remains high enough to maintain efficient control. If several human-driven cars join the queue, or if the number of autonomous vehicles drops below a certain threshold, the system gracefully transitions back. The central computer would end the white light phase, deactivate the cooperative mode, and switch the intersection back to its standard red-yellow-green cycle. The handover is seamless. The white light turns off, and the green light might turn on, giving clear and familiar instructions to the remaining human drivers. The system is robust, intelligent, and always prioritizes clarity and safety for everyone on the road. All right, let's dive into Section 5. Smoothing the flow, the promise of uninterrupted travel. One of the most profound impacts of the white traffic light will be on the very nature of traffic flow itself. You see, today, traffic moves in a start and stop pattern. We accelerate from one red light only to brake for the next one. This stop wave phenomenon is, well, incredibly inefficient. It wastes fuel, increases wear and tear on our vehicles, and most importantly, it wastes our time. Every stop and start sends a ripple effect backward through the line of cars, creating congestion that can stretch for miles. It's a chaotic system born from the limitations of human reaction time and our inability to coordinate on a massive scale. The white light phase aims to dissolve these stop waves. By allowing groups of vehicles to move through intersections in a coordinated, continuous flow, we can begin to smooth out the journey. Imagine your morning commute. Instead of a series of frustrating stops and starts, you might approach an intersection, see the white light, and your car, or the AV in front of you, simply adjusts its speed slightly to merge seamlessly with the cross traffic. The goal is to minimize, and perhaps one day eliminate, the need to come to a complete stop at an intersection. This creates a more fluid, river-like movement of vehicles through the city's arteries. This improvement in traffic flow has a compounding effect. When one intersection becomes more efficient, it reduces the backup of cars leading to it. This, in turn, helps the next intersection down the line function better. It's a positive feedback loop. By deploying this technology across a city's major corridors, we could see a dramatic reduction in overall congestion. Studies and simulations conducted by researchers, including those at North Carolina State University who pioneered this concept, suggest that even a small percentage of autonomous vehicles can lead to significant improvements. As the number of AVs grows, the benefits will multiply, potentially cutting down commute times for everyone. This translates into tangible benefits for our planet and our wallets. The constant braking and accelerating of stop-and-go traffic is a major source of fuel consumption and carbon emissions. A smoother journey is a greener journey. By maintaining a more constant speed, vehicles operate closer to their peak efficiency. This means less fuel burned per trip, which reduces transportation costs for individuals and businesses, and lowers the overall carbon footprint of a city. The simple addition of a white light, powered by intelligent communication, could be one of the most effective tools we have in our fight against urban pollution and wasted energy. Beyond efficiency, the most important promise of autonomous vehicle technology, and by extension the white light system, is safety. The vast majority of traffic accidents today are caused by human error. We get distracted, we get tired, we misjudge distances, or we make poor decisions in a split second. Intersections are particularly dangerous hotspots where these errors can have fatal consequences. They are complex environments with multiple conflicting paths, and the potential for a catastrophic mistake is always present. The white light system is fundamentally designed to engineer human error out of the equation, at least during the moments when it's active. When the white light phase is engaged, the intersection is being managed by a system with superhuman capabilities. The V2X communication network gives it a 360-degree, all-knowing view. It knows the exact position, speed, and trajectory of every connected vehicle. It doesn't have blind spots. It doesn't get distracted by a text message or a song on the radio. It calculates the safest path for every vehicle based on pure mathematics and physics. This computational oversight can prevent the types of collisions that are common at intersections, such as T-bone crashes from running a red light or side swipes from improper lane changes. This enhanced safety extends to pedestrians and cyclists as well. The V2X network is not limited to just cars and traffic lights. Pedestrians with smartphones running a compatible app, or cyclists with a small transmitter on their bike, can also become part of this digital conversation. The intersection's computer would be aware of a person waiting to cross the street, even if they are obscured from a car's direct line of sight by a parked van. The system can then pause the flow of vehicles to create a safe crossing window. It transforms the intersection from a purely vehicle-centric space into a truly multimodal environment that protects its most vulnerable users. Even for human drivers who are simply following the flow, the white light phase creates a safer, less stressful environment. It reduces the number of complex decisions a driver needs to make. Instead of monitoring cross traffic, watching for the light to change, and anticipating the actions of other drivers, their primary task is simplified to maintaining a safe following distance. This reduction in cognitive load makes it less likely for a driver to become overwhelmed and make a mistake. In a universe governed by probability, the white light system works to stack the odds dramatically in favor of a safe outcome for every single journey through the intersection. The impact of a network of white light-enabled intersections extends far beyond just the movement of cars. It has the potential to reshape our cities and our daily lives in subtle but profound ways. Consider the world of logistics and commerce. Delivery trucks and freight vehicles spend a significant portion of their time stuck in urban traffic, burning fuel and losing precious time. By smoothing traffic flow, the white light system can make urban logistics dramatically more efficient. Goods can move from distribution centers to storefronts faster and more predictably. This could lead to lower shipping costs, fresher produce in our grocery stores, and a more resilient supply chain. Emergency services would also see a monumental benefit. When a police car, ambulance, or fire truck needs to get through traffic, V2X technology can clear a path for it automatically. The emergency vehicle would broadcast a priority signal to every intersection on its route. The traffic light computers would immediately work to turn all lights red for conflicting traffic and give the emergency vehicle a continuous green light, or more accurately, a clear path through coordinated white light phases. This green wave for first responders could shave critical minutes off response times. And in the world of emergency medicine, minutes can be the difference between life and death. Think about the design of our cities themselves. We dedicate an enormous amount of land to roads, much of which is designed to handle peak congestion. We build wide avenues with multiple turning lanes just to accommodate the inefficient stop-and-go waves of traffic. If we can move vehicles through intersections more efficiently, we might not need as much asphalt. A 3-lane road might be able to handle the same volume of traffic as a 4-lane road does today. This could free up valuable urban real estate. That extra space could be reclaimed for wider sidewalks, dedicated bike lanes, green spaces, or parks, making our cities more livable and human-friendly. Finally, consider the data. Every interaction within the V2X network creates a stream of valuable, anonymous data about how the city moves. City planners and traffic engineers could use this information to understand traffic patterns with unprecedented detail. They could identify persistent bottlenecks, optimize signal timings across the entire city grid, and plan future infrastructure projects more effectively. This data-driven approach to urban planning would allow cities to adapt and evolve in real time to the changing needs of their populations. The white light isn't just a traffic signal, it's a sensor, feeding a citywide intelligence that helps us build the cities of tomorrow. The transition to a future with white traffic lights will not happen overnight. It will be a gradual process, likely beginning in controlled environments and expanding outward. The first places to see these new signals will probably be specialized testing grounds. Places like the University of Michigan's McKighty, a 32-acre simulated city environment built specifically for testing connected and automated vehicle technologies, are perfect candidates. In these controlled settings, researchers can push the system to its limits, test different algorithms, and ensure the technology is robust and safe before it is ever introduced to the public. These living laboratories are the cosmic nurseries where future technologies are born and raised. Following successful testing, the initial public rollouts will likely be targeted and strategic. We might see the first white lights installed along a specific high-traffic commercial corridor in a tech-forward city. Think of cities already known for embracing innovation, such as Pittsburgh, with its long history of autonomous vehicle research, or Phoenix, which has become a major hub for AV ride-sharing services. These cities have the political will, the research partnerships, and a population that is becoming accustomed to seeing autonomous vehicles on their streets. A single, well-trafficked boulevard could serve as a real-world pilot program to gather data and demonstrate the benefits to the public. Another likely starting point is in newly developed areas or planned communities. When you are building a city district from the ground up, it is much easier to integrate new infrastructure like V2X-enabled traffic signals. Instead of retrofitting old systems, you can lay the fiber optic cables and install the necessary computing hardware from the very beginning. Master-planned communities, particularly those with a focus on sustainability and technology, could be designed around this concept of connected mobility. These smart districts would act as showcases for the world, demonstrating what a fully integrated, efficient, and safe urban transportation system looks like. The expansion will be driven by data and success. Once a city demonstrates a measurable reduction in congestion and accidents along its first white light corridor, the pressure to expand the system will grow. Neighboring cities will take notice. State and federal transportation departments will develop standards to ensure that the system used in one state is compatible with the system in another. Just as the red, yellow, green system became a universal standard, the protocols for the white light phase will need to be harmonized. This slow, steady, and deliberate rollout ensures that the technology is deployed safely and effectively, paving the way for a national and eventually global network. As we look toward the horizon, the white traffic light is more than just an engineering novelty. It is a beacon signaling a fundamental transformation in our relationship with mobility. It represents the moment where we begin to move from a system of individual competing drivers to a system of collective, cooperative intelligence. This is a paradigm shift as significant as the invention of the automobile itself. We are teaching our infrastructure to think, to anticipate, and to coordinate. We are building a nervous system for our cities, and the white light is one of its most visible and important neurons. It's a sign that the city itself is waking up. In the long term, as the percentage of autonomous vehicles on the road approaches 100%, the traffic light as we know it may fade into history. In a world where every vehicle is connected and communicating, there may be no need for traffic lights at all. Intersections could become zones of continuous flowing movement, where vehicles seamlessly negotiate passage with each other without any external signals. The white light, therefore, is a transitional technology. It is a bridge between the present we know and the fully autonomous future we can imagine. It is the crucial evolutionary step that allows humans and machines to share the road safely during a decades-long transition period. The implications of this future are vast and inspiring. The time we currently waste sitting in traffic, which amounts to billions of hours of lost human potential each year, could be reclaimed. We could use that time to work, to learn, to connect with family, or to simply gaze out the window and wonder. Our cities could become quieter, cleaner, and safer places. The air could be clearer, the streets more open for people, and the constant stress of navigating congested roads could become a distant memory. This is the grand promise of a truly intelligent transportation system. The universe is full of complex systems that achieve a state of harmony and order, from the orbits of planets around a star to the intricate patterns in a snowflake. With the white traffic light and the technologies behind it, we are attempting to bring that same kind of elegance and order to the complex system of our cities. It is a bold and ambitious endeavor, born from human curiosity and our unending drive to solve problems. The next time you find yourself waiting at a red light, take a moment to imagine a fourth light, a white one, and consider the remarkable, coordinated, and safer future it represents. The journey is just beginning.